Okay, now this video is on the second part of 1.4 where we're going to be squaring some binomials and finding the difference of two squares. Again, you should be familiar with this. If you've never seen this stuff before, please come talk to me or send me an email so I can give you some more in-depth materials. Also in your book, you might want to check that out for more details. So the concept here, I'm going to go over something that students often, even after they've done this, they make mistakes with. But if you understand the concept, hopefully you won't do that. So if we want to find the quantity of 2 plus 3 all squared, this is a binomial. It's similar to, I'm going to write over here off to the side, a plus b squared. And sometimes people just want to do a squared plus b squared. That's what that equals. But let's see if that would actually be true. So, you could figure out 2 plus 3, we would calculate as 5. And then if we squared it, we would end up with 25. Now, does that actually equal 2 squared plus 3 squared? Can we just do that? It's kind of like using the distributive property, but when we have exponents, remember it's different. We really need to apply the power rule to our entire quantity. So I'll show you why this little shortcut that sometimes people make does not work. So does that calculate out? Let's see. 2 squared plus 3 squared, that would be 4 plus 9. That actually equals 13. So 25 does not equal 13. So I cannot do that. So a plus b all squared in parentheses is not ever equal to a squared plus b squared. So remember that. What it is equal to, I'm going to write again here, a plus b in parentheses, quantity squared, is going to be equal to the entire expression, a plus b in parentheses, times itself, a plus b in parentheses. So at first, take the time to do that and FOIL it out just as we did before. And then you'll notice, there's a pattern. We want you to see that it comes out to be a perfect square trinomial, and you can take those shortcuts after you've done it several times. You may already have that down and it's just really easy for you, but I see it a lot. So here, if we FOIL, we have a times a is a squared, plus the outsides would be a times b, plus the insides, b times a would be a times b. And the last is b times b, which gives us b squared. Now you can see here where I would have a plus b plus a plus b in the middle for my kind of my oi there. And so I'm doubling with the product of the two terms. So that will be a squared plus 2ab plus b squared. So that's your pattern in general. It kind of makes a formula. So you're welcome to use that, but do make sure you expand it out properly. So now okay, so number 9, we're squaring a binomial. This reads parentheses 2x minus 4 close parentheses all squared. So again, we can't just raise each of those terms to the second power. We need to raise the entire thing, 2x minus 4 with parentheses times 2x minus 4. Now we're going to FOIL that out. We're going to do it the long way, and then we'll see how that compares to the formula. So 2x times 2x would be 4x squared. Again, be careful of that. Make sure you square the number, because if you are doing that as 2x squared, using the pattern, I'll show you how that looks momentarily, you really need to make sure you get the 2 times the 2 in there, not just squaring the x. Another common mistake people make. So I have 2x times 2x is 4x squared. Then 2x times minus 4 is minus 8x. Now my insides, minus 4 from the first binomial times 2x is going to be minus 8x. And then the last term of each binomial is minus 4 times minus 4 would give me a positive 16. And then I need to combine like terms in the middle. 4x squared minus 16x plus 16. So you can see here where that the product of the two terms in the binomial is 2x times minus 4 would give me that minus 8. I have that twice, so it just doubles up. So if I were doing the formula for that, so my final answer here, just to restate before I go on to that, is 4x squared minus 16x plus 16. So using the formula, we should have the same answer. So a lot of times they do it as a capital A plus B squared, and that would be equal to A squared, whatever's in there. And if it's an expression like we have to square both factors, plus 2 times AB plus B squared. So in our problem here, we have that 2x is our A. So we have 2x in parentheses squared plus 2 times the 2x is our A. Our B is minus 4. So write that in parentheses. Make sure you have the sign with it. You might want to write it as a plus negative 4. And then finally, plus b squared. Now remember that minus 4 is in parentheses. And we need to, sorry about that, I shifted a little there. We need to raise that in its entirety as a quantity, negative 4 squared. So when we go ahead and simplify all that, we're going to get 2x all squared, so that's our 4x squared, plus 2 times 2x times negative 4, so that gives us our minus 8x. I'm sorry, 16x. I'm doubling there. And then we have our plus negative 4 all squared, the negative inclusive, so we are going to have a positive 16 on the end. So my final answer there is 4x squared minus 16x plus 16, and that is a match to what I had earlier. Okay, just a few more here. I'm going to do this number 10 as using the formula. So just follow along. So we have quantity 3x plus 4y cubed, all raised to the second power. So my A is 3x and my B is 4y cubed. So my first thing I'm going to write following the pattern is 3x in parentheses squared. Then I have plus 2 times AB. So my A is 3x, so I want to write that in parentheses. And then the next part of my formula is to multiply by whatever the second term is. We're calling that B. And ours is 4y cubed. Now on the end, it's a positive, so my B that we're looking at is parentheses 4y cubed and parentheses all squared. So you have to make sure whatever that second term is also gets put in parentheses. Now we can simplify, apply our product to power rule. So we have 3 squared is 9, x squared is x squared. Then plus 2 times 3x times 4 times y to the cubed, or cubed, would give us 24 xy cubed. Then adding the 4y cubed all squared would be 4 squared would be 16, and the y cubed squared is y to the 6th power. So our final answer is 9x squared plus 24xy cubed plus 16y to the 6th. And that gives us a perfect square trinomial. Okay, number 11, we're going to look at the difference of two squares. That's how this answer will come out. 2 plus 7n, that's all in parentheses, times the other binomial is 2 minus 7n. So they're pretty much the same, except they have opposite signs. So let's do our first outside, inside, last FOIL thing, distributing, to see what happens. So if we do our first, 2 times 2, I'm going to get 4. 2 times negative 7n, I'll get negative 14n. Now I'm doing the 7n times both terms of the second binomial. 7n times 2 gives me a plus 14n. So right there you can see what's going to happen. Or you can tell, whatever. And then 7n times negative 7n gives me a minus 49n squared. Okay, so this one is a little different because you're used to seeing the variable part usually coming first in that first term, the lead, but in this one it doesn't. Now cancel means that they literally go out to 0. So I have my first one is 4 and then minus 4n plus 14n. When I combine those like terms, they just cancel right out and I have minus 49n squared. So now you can notice that 4 is a perfect square. We have this subtract, which is a difference. That's what we call it. 49 is a perfect square and n squared is a perfect square. So my final answer is 4 minus 49n squared. It's a difference of two squares. So if you saw that and when we work in reverse, I always want you to start thinking in reverse whenever we're doing, especially the multiplying the binomials. Think, how would you undo that as in factoring? And again, I'm sure you've done plenty of that, but it might have been a while. So this one, if you notice that it's a difference of two squares, it makes it really easy to factor. Number 12 says quantity in parentheses 6n plus 1 times another binomial in parentheses 6n minus 1. So again, I see those same two terms in the binomial. They have opposite signs. So I'm going to say, well, that's going to come out to be a difference of two squares. So I'm recognizing a pattern. If I wasn't sure, I could FOIL it out. But on this one, I know that my 6n squared would end up being 36n squared. And then I'm going to have a subtract. And the square of my second term is 1. Because the middle term would end up being negative 6n. And plus 6n, that would go to 0. So my final answer is 36n squared minus 1. So my pattern here for a difference of two squares, which we can abbreviate DOS, would be A plus B times quantity A minus B, so both of those binomials are in parentheses, is going to equal A squared minus B squared. Now there's nothing that would just come out to A squared plus B squared in these cases, so just be careful of that. So that's it for 1.4. Then we're going to get into the factoring next. So thank you for watching. Have a great day.